Solve n squared minus 4n equals 0. I'm going to rewrite that down here. And this is slightly different from the last one, but it ends up being a very important difference. This is not a difference of two squares. If it was just n squared minus 4, it would be a difference of squares, but n squared minus 4n is not a difference of squares. We need another method for factoring, and that method is GCF. The very first thing we should always do is look for a GCF, and this is a really good example of why we need to do that. In this problem, there is a common factor of n in both of those terms, so we can pull out an n, and then that leaves us with n minus 4 as our leftovers. And this factorization is very different from the one we had in the last problem. So we need to be very careful when we're looking at whether or not something is a perfect square and whether or not there is a common factor, because a tiny difference will make a huge difference in how we solve some problems. Now we factored this, so we're going to set each factor equal to 0. The first factor is n, so we have n equals 0, or the second factor, n minus 4 equals 0. And n equals 0 is already solved. It's just n equals 0. We can just bring it down. The other one, n minus 4 equals 0, can be solved pretty easily. If we add 4 on both sides, that gives us n equals 4. And so we have our two solutions, n equals 0 or n equals 4.